to demonstrate using the SUR and WHS 2000 with Rcode transmitters. So the first thing that we want to do is to set up the SUR or WHS. In the case of the WHS, it's preset to be listening for Rcode transmitters. In the case of the SUR, it needs to be configured to do so. So we do that by using either host software from Lowtech or SurSoft from Sonotronics. And the first thing we'll do is to connect. I happen to know this is set to COM6 by can be verified in Device Manager, and when connected we'll see that the time and date and the ID and a number of records and stuff are shown. At this point it's good to make sure that the time is set. You can set either to a coordinated universal time or to local time, and I'll set that to our local time. And then I'm going to expose a hidden menu by clicking on the picture. Specifically, what is going to show up here of interest now is that we're set to listening to 69 kilohertz as the Rcode frequency, and the Rcode listening set to 200, which is gives us a value of approximately 32 seconds for listening. Since the Rcode transmitters ping infrequently, that number is going to need to be matched so that it's equally just a little bit larger than the largest amount of delays for your Rcode transmitters. Note that the longer that's set to, the bigger impact it has on the battery life. But in this case, I'm just going to be setting this for 69 kilohertz and for only listening for that one frequency. So when we're done with that, we're now ready to actually disconnect the SUR or the WHS and deploy it. So we can imagine that we've already done that. We brought it back from the field, and now when we're ready to process that, one of the first things we want to do is to set up a directory or folder where our test information is, and then get ready to download that. I've actually made a test folder named test, and we maneuver to that folder, and then when we go to download, we'll actually download the data and put it into this test folder. I've already taken the liberty of adding putting some files in here, kind of like when they pre-make the cake, but so this we'll assume that this is already done. We're now complete. We're now done with SurSoft. We can put the receiver beside it, out of our way, and if we can actually examine the data, the raw data that was collected in this case. Here we can look with Notepad and actually examine what the data looks like. It is readable with a time and date, and a flag here that indicates the kind of receiver and the data, or the kind of transmitter and the kind of data received. That's not a necessary step, but sometimes that's adds some confidence in our data collection. The next thing we're going to do is to use the SurSoft Data Processing Center software to actually analyze this data. And we do that by, again, setting the project folder to where we had downloaded the data, in this case test. And then a very important step is to loading the tag list. In this case, there's one already been created that comes with SurSoft EPC, and it includes the different Rcode types. In this case, the 320 happens to be the R64K code, RC380 is the R4K code, and the X300 is the new global tag that's being discussed. So then we'll actually look through the file of collected data, the raw data set, to find what tags are collected there. So here we see that there were 7 Rcode transmitters with that particular ID that's already been decoded. And in the case of the new codes, this has been we have a number of these that are not actually decoded. So what we do next is we go ahead and export the processed SUR file, and then this is where we take some additional steps. We take a look at the processed file, and we introduce a new tool. This is our little Rcode black box decoder box. And really what it does is it produces a series of pings, and we have a simple application that allows us to talk to this. We connect. I happen to, again, using Device Manager, this happens to be COM port 7. It shows that it's connected, and we can actually hear what this sounds like on a manual receiver like the USR08, and run a simple test. And those that are familiar with that sounds like an Rcode transmitter. We can actually apply this to another device and see that the actually LEDs blink. In this case, I need to hold it fairly close here because it's a low-level signal. And that extra blink at the end indicates that it was actually decoded. So that's fine for the test. Now for the actual data, we can go into the process data file and get this big number that represents the code, and paste that into the file. The software here breaks this down into the elements that comprise that code, and this we can transmit that code, and that long blink at the end indicates that it was actually decoded. So now we've actually collected that data. We can close this, and we can actually take a look at what a typical data set looks like. This data that was collected, we can open this with Notepad. And there we see the code that was collected here. The last one being the 230 being the ID. We'll take this information, go back to the data processing center, and actually open under File the tag translation utility. One other step that's necessary is to go to the test area and open up the translate file that we use, the batch file, and we'll gather the information from the processed file, the tag ID that was collected, and make a copy of that. Add another line for that ID, and from the translated value goes into here. We'll cut that, paste that into the utility. We'll save that. And now we'll take the processed file, open that, use the translate file that we developed, and show the translation utility. And then I'll save this as processed. And complete that process. Now I can go ahead and close these and take a look if I'd like with any utility I'd like to look at, and see that we have the raw data that was collected and the actual translated value that was determined by the black box and using